Alright guys, welcome to Math 0106. This is lesson 19. We are talking about percent notations. I've been alluding to this for quite some time. Now it's time to talk about it. So what is a percent? So this is the symbol that we typically see for percent. What this symbol means is, this literally means out of 100. Okay, so this is why, this is as a student, you should be very aware of what a percent is, because your grade is usually out of a percent, right? So if you take a test and it says 80, you get an 80 on a test, that means you get 80 out of 100. If you get a 97 on a test, it means you get a 97 out of 100. And this is usually how we talk about things. If you like sports, you have a free throw shooter who shoots 85%. That means per a large quantity of shots, he's going to make 85 out of 100, right? If we're talking about a baseball player, if he hits 20%, that means he hits the ball 1 out of every 5 times, or 20 out of 100 times, et cetera, et cetera. So it's just really 100 is a nice number to work with, so that's why we use percent. Okay, so with that in mind, let's look at the first question. So it says write each decimal as a percent. So let's think for a second here. What does 0.00554 mean? This means that we have, if we count, we see we have 1, 2, 3, 4, 5. So this is the same thing as saying 554 over, what did I say, 5? So that means I have 5 zeros behind. 5 zeros behind. There we go. Let's make sure I did that right. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Perfect. Okay. So we said a percent is out of 100. So what would I have to divide 100,000 by to change that so I have only 2 zeros? Well, that would mean I would divide by, almost wrote 3, but I have to actually divide by 100, which means I would move the decimal place over 3 spots. Now, if you think about it, if we go back to the original question, let's erase all of this. Actually, it's probably easier for me to erase this way. So if I erase everything related to this problem, what I really did, remember we got 0.554 as the final answer. What I really did is I just jumped 2 places. And that's really all you have to do. So in number 2, all I have to do is jump 2 places, and this is 11.9. So going back to the baseball example, if you bat at a .119, you're hitting 11.9% of your shots, and that's what those numbers mean. So let's look at number 3. It's kind of the same thing. It's just given as a word problem. So it says, the Swade family saves 0.1217 of their income. Write this decimal as a percent. So again, I just move the decimal place over 2, and they save 12.17% of their income. There we have it. Now, number 4, we're doing the same thing, only in reverse. So if we moved 2 places to the right, to convert to a decimal, it's the reverse. So we jump 2 places to the left. So this is just 0.35. 2 places to the left means I'm going to add 2 zeros. And this is going to be 0.0039. And even with this, don't be intimidated. You move over 3, it's 1.7 or 1.70. There we have it. Now in this number 7, we're going to convert into percents. But again, this is just looking intimidating, right? So we know if we want to convert into percents are out of 100. So notice that if I multiply 50 by 2, I get 100. So all I got to do is 27 times 2. If you double 27, that is, I'm sorry, I said 27, I mean 29. That's 58. Now, in number 8, it's a little bit more difficult because 5 does not go, 12. Figuring out 12 times what gives me 100 is a little difficult. So when this is the case, let's divide. So we're going to do 5.0 divided by 12. Notice I quickly rewrote it as 5.0 because I knew 12 doesn't go into 5, so I had to go to 50. Again, if you're struggling with these notions of division, I encourage you to go back and watch the videos that I've done on long division in order to better grasp it. So 12 plus 12 is 24. I'm just going to continue to add 12. This is going to get me 36. Add another 12. We're at 48. At another 12, we're at 60, and this is where I go bust. So let's see, how many do I have? 1, 2, 3, 4, and at 5, we go bust. So we know that this works 4 times. This will give me 48. We're going to get 20 here. And obviously 12 goes into 22 times, so this becomes, I said two times, but I should have said 1 time, because 2 times is 24. And this is going to give me 8. We're going to include another 0. And we're just going to keep adding here. So add another 12, we're at 72. And then if I add another 12, I'll go bust at 84. So this is the 6th time, and we go bust at 7, so it works only 6 times. So give me 72, which then if we do again, we get another 80. So this means that we're going to repeat here in the back with 4.16666. So remember that it's been a while, but the goal is to convert it into a percent. So we said we just move over 2. So this is 41.6 repeating percent. There's a lot of math there. Okay, so if we look at the next one, we have 7 over 15. Let me fit this. I'm struggling here to push the page down. But let's say 7 over 15. Again, we want to convert this into a percent, but 15 is not easy to multiply by to convert into out of 100. So again, we'll go back to some long division. 7 goes inside, 15 goes outside. 15 is the divisor, 7 is the dividend. Again, we put the 0.0 because 15 doesn't go into 7, but 15 does go into 70. So we'll keep adding 15. This is 30. Add another 15, we're at 45. Add yet another 15. We're at 60. Add one more, and we go over at 75. So how many 15s do we take? 1, 2, 3, 4, and we go bust at 5. So it takes 4. This brings me down to 60. 10, add another 0. How many times does 15 go into 100? We don't know, so we're going to add another one. This is 6. Add another 15. And we go bust at 7. And actually, I don't like the way I wrote that. Let me put 6s. I'm counting the 15s. Sorry, my mind was going on autopilot. So it only works 6 times. So we'll get 6. We'll put a point here. We know that 15 times 6 is 90. And now we can see we're just going to keep repeating with 100. So this is 4.666. The question, if you recall, says round to the nearest hundredth. So our place values tell me that this is the 10th. This is the 100th. So I look over here. So this means I got to round it back up. So this is going to become, 40. Now, hold on a second. It says round to the nearest 100th percent. So first off, we move 2 places. This is 46.666 repeating, which is 46.67, because we're talking about the 100th percent. So I have to first write it as a percent, and then I round, which is 46.67%. Okay, so I think I've filled up this page pretty much. Let me go to the next page, and let's look at it here. So we are at number 10. It says write each percent as a fraction or mixed number in simplest form. So if we have 10.276, this is as a, well, let's just say it's a mixed number here. Actually, we really want to say it as a fraction. So this is just 10.276. If it's a percent, it's just out of 100. And so that's what it would be. If I wanted to convert it to simplest form, then I want to move first off the decimal place 3 places over. So that would imply that I would multiply the top by 1,000, because that would make the number bigger, which means I got to multiply by the bottom by 1,000. So this is 10,276 over. Now if I have 1, 2, 3, 4, 5 zeros, I have 1, 2, 3, 4, 5 zeros. And then I would take this number and I would reduce it. So this is a little not difficult, but it is a little, I would say, maybe the right word is annoying. But let's go ahead and reduce. So we're going to divide. Look, I know it's even, so let's just divide by 2. 10 divided by 2 is 5. 2 divided by 2 is 1. 2 doesn't go into 7, but we know 70 divided by 2 is 35. So 6 would mean 3 more. So what did I say? 70 was 35, so this is 38. And half of 100 is 50, so this is 50,000. Okay, so it worked with 2. These are still divisible by 2. So we'll do it again. So 5138 is not as pretty. We could technically do it in our heads, but let's just go ahead and do it long division. This is 2, 4, 1, 11. This would be 5 because of 10. This would be 6 because of 12. And this would be 9. So we have 2569. If you wanted me to do this in my head, the way I would think about it is I would think of it as 5,000 plus 100 plus 38. And I would divide each of these by 2. So this would be 2,500. This would be 50. And this would be, in my head, I think 40 divided by 2 is 20. So this would be 19. That's 69. That's 25. So it's 2569. That's how you would do it in your head. I did a long division because I think it's a little clear. But if you actually get comfortable in doing it this way, it's really not as hard as it seems. The bottom is just going to become 25,000. So we have 2569 over 25,000. Now, we know that the bottom is not divisible by 3. So at this point, there's not going to be a very straightforward number that works with both of these. So at this point, with the scope of what we've done in this class, if this was multiple choice, you would either get here and then you realize it's one of the answer choices, or it wouldn't be one of the answer choices. So you'd have to just figure out what it would be divisible by. And you'd have to just play. Let's see, hey, maybe 7, maybe 11, maybe 13. You just have to keep playing with numbers until you find one that works. This actually doesn't reduce any further. And this is actually the final answer. So there you have it. So you may have to play with multiple choice answer choices to try to figure out if this would be the case. I'll let you guys know if on the final you have something this complicated. On my exams, I wouldn't put something this complicated on there. I would make it a number that you could easily tell that it works. So let's go on to the next one. So this one is 185 and 5/7. I'm not a big fan of 7. Here I'm actually going to apply what we call the Texas method to this one. So we have 185 times 7, that's 35. 5 times 7 is 56, plus 3 is 59. 7 times 1 is 7, plus 5 is 12. And we'll add 5 to that, which gives me 1,300. So now I have 1,300 over 7, to which I will apply long division to. So we know 7 goes in 13 one time. You know what? Let me just still add 7s here and we get 14. So we know it goes in one time because at 2 we go bust. Here's 1. Here's 2. This is going to give me, I always love doing that, 13 minus 7, which is 6. We'll tack on the 0. You know, I could keep listing, but you should know your powers of your 7s. 8 times 7 is 56. So this would be 56. It's going to be 40. 7 goes into 40. Well, we know 5 is 35. 6 would be 42, so it'd go over. So this is 35. This would give me 50. This would be 7 times. And at this point, we're getting decimals here. This would give me 49. When we subtract, we get 10. We're going to add another 0 here. This would be 1. 1 times 7 is 7. We'll tack on another 0. And 7 goes into, that would be 28. And we could keep going, but I think this is sufficient. Let's see here. What does it say? I think this is sufficient. This would give me 185.714. Now, if we're converting into a decimal, into a percent, we're in decimals, right? Percents, we say we just have to move over 2. So this would be 18571.4%. So remember, when we think about this, percents, sorry about that. When we think about this, percents are always, oh, I'm so sorry, we're in percents. So we're going to go in the opposite direction. Sorry about that. We're in percents, so this would go in the opposite direction, be 1.85714. So if you're going from decimal to percent, percents are bigger than decimals. But if we're going from percent to decimal, decimals are less than percent. So so keep that in mind in terms of the size. So let's say that again. So decimals are less than, percents are greater than decimals, I guess. This symbol here means greater than. Let me be clear with the symbol. This looks more like a 7 than a greater than sign. So percents are greater than decimals. Okay. Or decimals are less than percent. Okay, let's do the next one on another page. So here we actually have a number 12. This is a simple situation because we have 16.66 repeating percent. We know 2/3 is 0.666 repeating. We can rewrite this as simply just 0.1666. I wanted to almost write percent, but 1.16666 as a decimal. And there we have it. So that's all that's necessary to do there. Okay, let's move on to the next one. Okay, so the next one is to write 4/75. It says write the equivalent decimal in percent for 4/75. Okay, so we want to convert this. Now, this is a little difficult because 75 doesn't convert into 100 very easily. So again, we're going to write 4 and 75. Notice 4 goes in the inside. Now, the trick here is that you actually need 2 zeros because 75 doesn't go into 40. So we got to do 400. And so let's just list. So 75 plus 75 is 150. Just think of 6 quarters. Add another 75, we're at 225. Add another 75, we're at 300. And we need to go to what, 400? So we know the next one's going to work. But we'll add one more, which puts me at 450. And so this is 1, 2, 3, 4, 5, and we go bust at 6. By the way, I don't know if this is clear, but when I'm doing this, what I'm actually doing for every other one is I'm adding 150. So I'm sitting here, I'm going 150, 300, 450. So again, just to be clear here, here's 150, here's 300, here's 450, and that's how I'm doing that. I'm actually doing by 150s because adding 15 is pretty easy in my head. So we know that, what did I say? We know that it works 5 times, and the 5th time gives me 375. That's why I like to do this. So subtract, we get 225, and so I have to tack on another 0. So this would be 250. The question is, how many times does 75 go into 250? Now this is why I like this method, because I can see that it goes in 2 times, because on the 3rd we go bust. So it works 2 times and gives me 150. We subtract, we get, am I right there? I'm sorry, I made a mistake. I can't read. It goes 225 because that's less. So it's not 2 times, I apologize. It's 3 times because that gives me 225. 225 is less than 225 is less than 250. Okay, so it works 3 times. Now I want you to notice something, and this is a good point to illustrate here. When I originally had done this, I said 150, and if I was solving this, I would have gotten 100. Because 75 does go into 100, I know I made a mistake, and that's actually exactly what I did there. So that's why I knew it was going to be 3. Now the next bit here is that if we look at this, we kind of are getting a repetition here. So we now know that this is 0.533 repeating. I like to write multiple 3s or whatever the digit is repeating, because I think visually it makes it stick out more. You actually can write it just once and that's sufficient. This is the same thing as saying 53.33%. So again, all you have to do is jump 2 decimal places and you're back to percents. So there you have it. Let's do number 14. So 14 is asking us to write this as a fraction and as a percent. This is actually easier than the previous example. So this would be 12 over 100 because we moved 2 places. So that's how you write it as a fraction. As a percent, it would be 12%. Now, can we reduce 12 over 100? Sure. Go ahead. I'm going to be efficient here. I'm going to divide by 4 because I know each of them are divisible by 4. This is 3 over 25. So you'd have to read the question carefully. If it says reduce, then you'd put 3 over 25. If it just says to convert, don't worry about simplifying. 12 over 100. But as a percent, you just jump 2 places, and it's 12%. So let's go on to number 15. It says write the equivalent fraction decimal for 33 1/3%. So 33 1/3, we know 1/3 is 0.333 repeating. So I'm just going to write it as such, and I'll put a line over all these 3's. So percent is out of 100. So if it's out of 100, that means we're going to move 2 places forward. So this will become 0.3333 repeating, which, by the way, we know is 1/3. So you can see the emphasis here that if you memorize those fractions I told you in the previous videos, then your life becomes a whole lot easier with these sort of questions. Let's look at the next one. And the next one is actually something new here. You need to make sure you know this. You're going to probably see 1 or 2 questions on the final related to this. And all you need to do is learn how to convert from words into math. The word of means to multiply. And the word is means equal. So I want to use the symbol as equal, but the word means equal. This gets a little confusing. And what is what we're going to put as a variable. That's what we're solving for. The issue here is that really, we're not really supposed to be stressing algebra, but if you kind of need algebra in order to do this, so So bear with me, it's very minor algebra. What we have here is 54%, which is percents are out of 100, so I'm going to write 54 over 100. Of means to multiply, so times 74 means equal what? What is x? So we're going to solve this. I misspoke here. We actually don't need to do algebra because everything's on the left-hand side. So we would multiply this out. If we multiply this out, we get 3996 over 100 is x. Now, I'm not going to bother with what 54 times 74 is. You can work that out for yourself. If the question asked me to leave it as a fraction, I would do this. If the question asked me to write it as a decimal, we know that this is 39.96. As a percent, it's 39.96%. And the reason why we know that is because percents are always out of 100, so it's just the numerator. And there you have it. In number 17, we have what, so that's x, means equal 14.4%, so that's 14.4 over 100 of means multiply 86. So again, we just have to solve this. We have to multiply 14.4 times 86. Actually, you know what I'm going to do? I'm not going to concern myself with that. We know that when we do this, we end up getting 1238.4 over 100. Okay. You can multiply this out. And if you really want to see me multiply these out, just let me know and I'll make a video of these problems worked out. For the time being, I'm just going to assume that you can multiply them out on your own. This means that as a decimal, I would move it over. It's going to become 1234. And as a percent, it would be 123.4% for the same reason as the other one, because they're out of 100. Now, for number 18, it says to give 3 different kinds of notation for 24%. So clearly, we can say 24%. We can also say 0.24. And we can also say 24 over 100. Now, you may see this reduced. If you look at the key, that's actually what they end up doing. They're both divisible by 4, so we get 6 out of 25. But essentially, there's the answer. So what I'm going to do here is I'm actually going to stop here because I got another page of math to do related to this section. We'll just go ahead and include that in as another video. It's going to take me more than, I have about 2 minutes left, 3 minutes left to finish it off. So that's not going to be enough time to do the next video, the next page. We'll stop here. Hopefully this makes sense. Let me know what you guys think. And, you know, as always, via comments or email. And if not, I will see you on the next math video.